Now we can again apply the tree method also to solve this particular given recursive expression or recursive equation. How? Again, what is the meaning of this particular statement? When the number of input is 1, at that time the time required is a constant time. That means the algorithm takes a constant time only. But when the number of input is greater than 1, the number of input is greater than 1, at that time what we need? We need to spend n number of time at that, and after that we can reduce the problem of n input into n minus 1 input. After that we can reduce the number of input, we can reduce the problem from n input to n minus 1 input, and to reduce one element from the input we need to spend n units. Clear? So let's start. Now we are using tree method. So initially the problem given as t of n. Now that this n is greater than n, so how much we need to work? We need to spend n amount of time. So we spend n amount of time. After that we can reduce the problem from n input to n minus 1 input. So left with n minus 1 input. Now look at here, whatever the number of input here, we need to work that particular amount of time. Clear? So now here the number of input is n minus 1. That means how long we need to work, or how many time we need to spend? We need to spend n minus 1 time, and after that we can reduce the problem into t of n minus 1 minus 1. That means t of n minus 2. Again the number of input reduced by 1, so it becomes n minus 2. Now again here in this case the number of input is n minus 2. That means how much we need to work? We need to work n minus 2 times, and then the number of input will reduce by 1. That means t of n minus 3 will come. Now look, every time we are spending some amount of time, and then the problem is reduced to a smaller problem. Like that, in every step how many elements we are reducing? In every step we are reducing only one input element. We are reducing only one input element. So total how many elements are there? Total n elements are there. That means to reach to our base condition, that is t of 1, how long we need to work? Again here also we spend t of n minus 3, and then finally we can reach to this. So in every step, point is, in every step we reduce the problem by one element only, and a total element we have n. So how many steps we need to reach, how many steps we need to apply before we reach to t of 1? That is our base condition. How many steps we need to reduce? That is, we need n minus 1 steps before we reach to t of 1. That means here how many steps we apply? Here we apply n minus 1 repeated steps. Clear? So after when we apply the n minus 1 repetition, and then we reach to this particular t of 1, that means after that how long we need to work? After that we need to work a constant time only, so it left with only 1. Clear? Now there is no t of now there is no t function, means time function. We left with only these numbers. So these are the time that we need to work at each phase or in each phase we need to work for this many times. In each phase we need to work for this many times. That means what is our total time? T of n will be n plus n minus 1 plus, like that it will continue till 1. So this is again sum of n natural number. That means we get n into n plus 1 by 2, that is n square by 2 plus n by 2. Again the dominating term is n square, therefore we will get T of n equal to order of n square. Clear? Hope you understood the concept, how we can apply the tree method as well as the back substitute method. But look, the result what we get is always same. Both process will give us the same result. Clear? That's it for this class. See you soon in our next class. Thank you.